All right, so we're looking at how to do the Hardy-Weinberg lab. So in that, I will be giving you the numbers, for those experiments. So you're not actually going to do the experiments. I'm going to give you the numbers that you would get had you done the experiment. So, and then I'm going to show you in this how to fill out these charts here. All right. So these are your raw numbers. So if you get two beans that are black beans, they would be big B and big B. So the big B represents the black bean. The little b represents the white bean. So if you pull out of the bag two black beans, then that individual would be big B, big B. If you pull out two white beans, that individual would be little b, little b. And if you pull out one of each, they would be heterozygous, big B, little b. All right? So our total here is 6 plus 13 is 19 plus 6 more is 25. And so that's what you should have because you put in 50 beans, right? To figure out how many big B alleles that we have, well, you have 6 of those big Bs, and then you also have 6 of those big Bs, so that's 12. And then you have 13 of those big Bs, and so that's 25, which makes sense because that's how many you put in. All right, now to figure out how many little b's you have, well, you have 6 of those little b's, and then 6 of those little b's, and then 13 of those little b's. So 6 plus 6 is 12, plus 13 is 25, and that once again makes sense because that's how many you put in. The total here together is 50. All right, so now to determine what all these are, p squared, 2pq, q squared, p, and q, remember p squared is the frequency of the homozygous dominance individual. So that's this. So in order to figure out what p squared is, we're going to have to take 6 and we're going to divide that by 25. All right? Because that's a total number of individuals there. All right? So 6 divided by 25 equals 0.24. All right? So here, 2pq is the frequency of the heterozygous individuals in the population. So if you take 13 and divide it by the total number of individuals in that population, which once again is 25, 13 divided by 25 equals 0.52. All right? So over here, q squared is the frequency of the homozygous recessive individuals in the population. So you're going to take the number of individuals that are homozygous recessive, you're going to divide it by the total number of individuals in the population, which is 25 again, and 6 divided by 25 equals 0.24. Now once again, these three numbers should equal 100% or 1. All right? To determine what P is the frequency of the dominant alleles. So you're going to take how many dominant alleles you have and divide it by the total number of alleles in that population. So this is 25 here divided by 50, which is equal to 0.50. All right? To figure out what Q is, you can take the number of individuals that, so Q is the frequency of the homozygous recessives, so it is the frequency of the recessive allele in the population. So you're going to take the number of recessive alleles and divide it by the total number of alleles. So once again, 25 divided by 50 equals 0.50. All right? So that's how you are going to fill out these charts. All right? Now there's a question at the end of this lab in which it asks you to do Hardy-Weinberg equations, and that's going to be similar to what I did on a previous video.